Welcome to Session 16, Powers of 10 and Scientific Notation. Scientific notation separates a number into a coefficient and a power of 10 scale. You will write large and small values in normalized form, convert back to standard notation, compare exponent size, and multiply or divide scientific notation values accurately. Scientific notation has the form a times 10 to the n, where the absolute value of a is at least 1 and less than 10, and n is an integer. The coefficient shows significant digits. The exponent shows scale. Coefficients such as 52 must be normalized to 5.2 with a different exponent. Write 0.00073 in scientific notation. Place the decimal after the first non-zero digit to obtain 7.3. The original value is below 1 and is 4 powers of 10 smaller, so the exponent is -4. The result is 7.3 times 10 to the -4th. Convert 6.04 times 10 to the 5th into standard form. 10 to the 5th is 100,000. Multiplying 6.04 by 100,000 gives 604,000. The positive exponent makes sense because the resulting value is larger than 10. Multiply 3 times 10 to the 4th by 2 times 10 to the -2nd. Multiply the coefficients to get 6. Add the exponents. 4 plus -2 equals 2. The result is 6 times 10 squared, or 600. The coefficient is already normalized. Divide 8 times 10 to the 6th by 4 times 10 squared. Divide the coefficients to get 2. Subtract the exponents. 6 minus 2 equals 4. The quotient is 2 times 10 to the 4th, or 20,000. Converting back confirms the expected magnitude. Checkpoint. Write 4,500,000 in scientific notation. The normalized coefficient is 4.5. Multiplying it by 1 million rebuilds the original value, and 1 million is 10 to the 6th. Choice C, 4.5 times 10 to the 6th, is correct. Create a coefficient from 1 up to but not including 10. Choose a positive exponent for large values and a negative exponent for positive values below 1. Add exponents in multiplication and subtract them in division. Convert back to verify scale. Continue learning and practicing at bridge2exam.com.